Okay. Decided we need to do this. I was going to motivate it by a numerical example, but because of some little discussion we had, we want to go ahead and do this. Okay? So, suppressing the t, we have x. And the c here is x of 0. This c equals x of 0. This c equals b of 0. Okay? So we solve this for t, and we find that t equals negative v of 0 plus or minus the square root of v of 0 squared minus 2 f x of 0 over m divided by 2 times this. Okay? That's just quadratic formula. There's your A, there's your B, there's your C. That's what you get if I did it right. I think I might have. Okay? Now you plug that back into V of t. Okay? And V of t is f over mt, right? Plus V of 0. Well, f over m times t is f over m times this. Okay? And this has an f over m in the denominator. So f over m goes away from this. Okay? But it's still going to be over here. So you're going to get negative v of 0 now, the f over m okay? And then we have plus v of 0. Which leaves us just this. And if you take initial conditions into account, you see your 2f over m times x here, except it's got a negative sign here, a positive sign here. Okay? And I'm not sure what's going on with that, because this is good. And whatever, well, that's 2f over m times x. Okay, your constant c will take care of that. Okay? And your v of 0 and all that stuff. Okay, because it gets a little more complicated. So, this is just this. Oh man, I left it out. There it is. That x of 0 should have been x of 0 minus x. Now there's not room to write it, so I'll have to write it over here. But then that gives you your 2f over m times x that you have here. Okay? And the rest of it is integration constant here. Okay? So let me write it out more clearly. What was that?
Your armadillo.
Oh, I was going to say, I hope it's not alive, but it's an aardvark, incidentally.
Oh yeah, that's what it was.
Okay? We don't do armadillos, of course, we do aardvarks. Increase this a little better. Oh. There we go. Okay. I got to sharpen the edges of these things just so I remember not to hit it with my hand. Okay? Okay. So, let me rewrite this last line. Give myself enough room. Okay, and we see that this solution matches this solution, or your integration constant, in this case, is just this. Okay? Now, you can work out whether the integration constant and your initial conditions for v of 0 and x of 0 actually give you this, if you use this one. Okay? But you see, you have to go through a fair amount of machinery to use this solution, where, in this case, boom, you've got it in just a couple of simple steps. Okay? So there's a big advantage to being able to do this. Okay? Let's look at another example. Never mind. I keep forgetting what symbols and what uses here. Okay, drag force. Okay, different authors use different symbols for the coefficient of a drag force. I can't ever keep track of which symbol's being used by whom. Okay?
All right.
So I use gamma here.
All right.
Okay? So, there it is. Find v is a function of x. Now you can find v as a function of t easily enough. You get, mv prime equals this, separable, boom, you got a solution for v. And then you got to integrate that to get your solution for x. Okay? like we did here, and then you'd have to do something like this. Instead, we want to do this using the MV, dV, dx for your net force, okay? And just for the heck of it, there's no reason not to do this. So you got like a constant applied force, but you got drag. You know, that applies to if you drop something, and you just have the linear drag force, okay? Drag force is a...
If you don't have the force in there, can you have drag? Like,
Yeah. Yeah.
I guess,
Consider the motion of a bullet. Now, that's not a good example. Let's just say a Nerf ball that I throw there, okay? The motion in this direction, the only force is drag, okay? Or I push off the wall in the pool and glide. I glide really interesting fast, you know, like a rock. But I push off the wall and glide. The only force, the net force, I don't have any net force in this direction.
right.
Because the buoyant force is balancing the gravitational force, right? Now that's kind of an ideal case because there's a glide force. You know, if I position my body aerodynamically because of my velocity in this direction, I also get an upward lift. Okay? And naturally, trying to avoid drowning, I can do that. And then trying to improve my times, I do that a little bit. And eventually I sort of optimize it, okay? The best I can. So anyhow, you then don't have any force in this, there's no applied force in this direction once my feet leave the wall, so I'm gliding.
It's just still the velocity is still up, so no force is being applied, but you still have velocity, and that is actually to slow you down.
Yeah, well, the force was applied, it's
Yeah.
not there anymore. Okay, that force is done, that force got me up to my speed, and now I'm gliding just with this, no applied force. Now, if I cheat, put a little motor on my back or something, you know, or if somebody's pulling me, could be a little different, okay? And of course, that's a problem, I mean, that's a good problem in its own right. And depending on whether it's gamma V or gamma V squared, you have different solutions. And we've done that,
Yeah.
okay? So you can relate that to what we've done. But now we want to directly find how fast am I going 2 meters from the wall? Okay? That makes sense? Or, you know, at what position should I make my stroke? Because I've slowed to the point where taking the stroke will
At the max gain.
increase my average velocity over what it would have been otherwise. Okay? Try to optimize.
Right.
When do I take my stroke? Okay? Makes sense? And that's a complicated question. I don't even know. I know when I want to take the stroke, but I've never analyzed it because my competitive days are in the long past. Okay, and of course I don't want to compete against old people because they wouldn't have a chance. I've seen some old people smoke me very, very, very effectively. Okay, not most of them, but some. Okay, so anyhow, and with injuries I don't compete. Okay, I'd hurt myself because I'd want to win. Okay, so, and I wouldn't win anyway, so what's the point of hurting myself to get something that's not going to happen? Okay, so anyhow, you can solve the differential equation for that decision also, okay? But you don't want to see it right now. And seriously now, when I swim, I think through all kinds of differential equations. I think there's an interesting differential equation. You know, we optimize the timing of this move or that move because it's a breaststroke, but it's very complicated as opposed to most other, compared to the others. And it's fascinating, and people have done mathematical studies on it, and it's all differential equations. Okay, just like everything else in the universe. Okay, so end of motivational part. Let's go ahead and see if you can find V of X for this situation.